Hi, my name is Muhammad Zulfadli bin Nasir, number matric A5735.
Hi, my name is Ahmad Yahya bin Ahmad Shukri. My matric number is A6868.
Hello, my name is Muhammad Amirul Haikal bin Muhammad Hafiz. My matric number is A6816.
Hello, my name is Abu Zar Shafi bin Johari. My matrix number is A6223.
Assalamualaikum warahmatullahi wabarakatuh. Good morning and hi to everybody that is watching this video right now. My name is Muhammad Adam Hakimi bin Arul Islam, and my group member consists of Muhammad Amirul Haikal, Abu Zar Shafi, Ahmad Yahya and Zulfadli. Now, we are all from group 10 of the mathematical assignments, and we are going to demonstrate to you how we use the heights of University Malaysia Terengganu students to calculate ungroup data. Let's go. Now, we did not just put these numbers randomly here. These numbers are based on statistical analysis of students' height that we have conducted via survey that has 32 respondents. Now, the variable that we study is students' height, and we actually count it in centimeters. So this is actually classified as quantitative continuous data. This is because height can be measured from any value within a range and is measured numerically. It is also considered ungrouped data because it is measured individually and not grouped into class intervals. The objective of this analysis is to calculate and interpret the central tendency and the measures of dispersion to better understand distribution of height among students. I think that is all from me. Now I'm going to pass to my friend to explain the measures of central tendency.
Thank you, Adam Hakimi. So, there are some data description that we need to calculate. The data description that we need to calculate is mean, median, mode, quartile 1, quartile 2, interquartile, variance, and standard deviation. First, we calculate the mean, which represent the average height of the student. The formula for mean is the total sum of all values divided by the number of observation. The total height of all 32 students is 5,194 centimeters. When we divide 5,194 by 32, we obtain 162.31 centimeters. Next, we determine the median, which is the middle value after arranging the data in ascending order. Since we have an even number of data, the median is calculated by taking the average of the 16 and 17 values. The median is 162 centimeters. Finally, we identify the mode, which is the value that appears most frequently in the dataset. The most frequent height is 166 centimeters. That's all from me. Now I will pass to the next presenter to explain the quartiles.
Thank you, Abu. Now, let's continue with my part. First of all, quartile divide the data into 4 equal parts. The first quartile is Q1, represent the median of the lower half of the data. The value of Q1 is 157.5 cm. The third quartile, Q3, represent the median of the upper half of the data. The value of Q3 is 168 cm. Using Q1 and Q3, we can calculate the interquartile range, or IQR, which measure the spread of the middle 50% of the data. The formula is IQR equal Q3 minus Q1. So 168 minus 157.5 equal to 10.5 centimeter. This means that the middle 50% of students have the head within a range of 10.5 centimeter. Now, I will pass to the next presenter, which is Amirul, to explain the variance and standard deviation.
Thank you, Ahmad Yahya. So now we calculated the measures of dispersion. We show how spread out the data is from the mean. First, we calculated the variance. Variance measures the average square deviation from the mean. The variance for this data set is 42.59 square centimeters. Then we calculated the standard deviation, which is the square root of variance. The standard deviation is 6.53 centimeters. This means that on average, students' height deviate about 6.53 centimeters from the mean height. This indicates that the data is moderately spread but not highly dispersed. Now I will pass to our final presenter for the conclusion, Muhammad Zulfadli.
Thank you, Amirul. So, in conclusion, the average height of the students in the study is about 162 centimeters. The mean and the median are almost the same, so the data is quite balanced and not strongly skewed. The interquartile range is 10.5 centimeters, which is mean the middle 50% of the students' heads are spread within this range. The standard deviation is 6.53 centimeters, showing that most students' heads are quite similar and not very different from the average. Overall, the students' head data looks balanced and close to a normal distribution, with no extreme outliers. Thank you for listening. Bye-bye.